Okay, this question is based on similarity. Okay, so we know that there are three tests for similarity. One is AAA, another one is SAS, and the third one is SSS. So depending on the situation, we can prove these statement. I mean to say this statement, that is CA square is equals to CB into CD. Okay, so let us see what is the information given here. Okay, here it says that there is a triangle ABC where D is on the side BC. Okay, such that angle BAC. So this whole is angle BAC. So if I have to remove this, it becomes angle BAC. So this whole angle BAC is equal to the angle ADC. Okay, so first we need to understand what is ours. So we need to prove that CA square is CB into CD. Okay, now if we look at this triangle, okay, so how many triangles are there if you look at the figure properly? So there is this triangle, this is triangle number 1, then you have this triangle number 2, and you have the whole triangle, that is triangle number 3. So we need to identify where you can find CA. Okay, so we need to draw, or we can draw two triangles separately where we can find CA. So if you look at the whole triangle, that is triangle ABC. In ABC, you can see that AC is here, right? That is CA, okay? And if you look at triangle ADC, that is triangle AD. So this is A, this is D, and this is C. So this AC is in the whole triangle ABC. It is also there in triangle ADC. So to prove this statement, okay, we have to prove that these two triangles are similar. So it can be either of these three tests, okay. It can be either through AAA or SAS or SSS. Okay, now if we look at what is the information given here, we are told that this angle is equal to which angle? ADC. So this is angle ADC here, right? Okay, now only the angle, one angle is given to us. There is nothing mentioned about the side. So this is out of question. We cannot prove by this method. Even this is not valid here because we don't know anything about the sides. So what is left out is AAA. Now if you look at this angle, that is angle C. So angle C is this. It is in this whole triangle, that is the bigger one, ABC, and that same angle is there in this triangle ABC also. Sorry, ADC. So you have angle C as a common angle in this triangle ABC as well as the triangle ADC. So these two triangles are equal, that because it is the same or the common angle, and this angle A is equal to this angle D here. Okay, so these two angles and these two angles, they are corresponding angles. So here the corresponding angles are equal. Now if two angles of two different triangles, they are equal to each other, then the third angle automatically becomes equal. So even if we say that AAA, we can, I mean to say that if two angles, you can prove that the two angles of these two corresponding angles are equal, then the third one need not be proved. So we can prove that these two triangles are similar by AA test. Now how? So to prove that, first we have to name it. Okay. If I start this triangle with A, okay, and then I go to C, and then I go to B. So I can name this triangle as ACB, and if I have to name this triangle here, so I can name it, see, this A is equal to this D here. So I can start this with D because here A is equals to D. So if I started this, naming this with A, I will start naming this with D. Then from A, I wrote C here. The second letter or the second vertex is C here. Now this C is equal to this C, so I'll write C here. Then what is left out is this B would be equal to this A here. Okay. Now this is very important because once you understand which angle is equal to which angle, then it becomes easier for us to prove the similarity by this test. Okay. Now these two triangles, I have named them. Now I'll say that angle. Okay. If I have to name this angle, I can call it as BAC. So if I have to name this angle, then this letter has to be in the middle, or this Okay, it has to be between these two letters. So if I say B, I start with B, then I come to A, then I come to C. So BAC. So similarly, I'll start with A, then I go to D, and then I go to C. So I'll say ABC, or sorry, BAC is equals to angle ADC. Okay, why these two angles are equal? Because it is given to us. Okay, so I can say given. Okay, now the other angle which is equal, or those two angles, that is this C is equal to this C. So I'll name it as ACB. ACB. So I'll say is equal to DCA, is equals to angle DCA. So that is why, see, I had already mentioned that we need to name it properly. Okay, we have to name it as per the given information, or we can say whichever angles are equal, accordingly you name them. Okay, so why these two angles are equal? Because they are common. Means that same angle is common to both the triangles. Not they, but it. Only one angle is there which is common. Okay, so therefore I can say, therefore triangle ACB is similar to triangle DCA. Okay, when the triangles are similar, okay, the corresponding sides and the corresponding angles, okay, the corresponding angles become equal and the corresponding sides are in proportion. Now we want CA, right? Because we need to prove that this CA square is equals to CB into CD. So if I look at CA here, so it will be like CA upon this CD, okay, will be equal to, now if I have to take AC from here, then why do I need AC or CA? Because it is CA square, right? So if I take CA from here, so that has to be in the denominator. Okay, so I'll take CB here. Okay, so what I need to write is corresponding sides of similar triangles are in proportion. When two triangles are similar, then the corresponding sides, okay, they come in a proportion, or there is a proportion which is made between the corresponding sides of similar triangles. Okay. Now this is the reason why there is a proportion between the corresponding sides. Okay, now after that, okay, what I can say is I'll shift this from here to here. Okay, so the second I'm writing here because there is a space problem. So this CA will multiply this CA. Okay, here it is transposed from right to left. On the right hand side, CA is dividing the numerator, so here it will multiply the numerator, and this CD is dividing CA, so here it will multiply, so that will become CB into CD. I'm sorry, I'll write it again. Okay, CA into CA is equals to CB into CD. Yes, now CA into CA is CA square, which is equals to CB into CD. So this is what was supposed to be proved. So we can say hence proved. Okay, so this is your answer or the solution for these kind of questions.